Hope you had a great weekend. We supersized our weekend. I like when we do that. Instead of a 2 day weekend, we decided that was not enough, so we made it a 3 day weekend. So thank you to the federal government, President's Day. President's Day gave us an extra day off school. So that's nice. I got a few things done around the house yesterday since I didn't have to be at school. So went to the comedy club this weekend for Valentine's Day. I did take my wife. That was nice of me, right? Take her with me. We saw a comedian who used to be an engineer, so it was the nerdiest comedy you've ever seen. It was great. I mean, I loved every bit of it. We went with another couple. We double dated, and the other lady, she's saying to her husband, "Hey, you didn't laugh at everything." He says, "I didn't understand everything." You had to be pretty nerdy to get most of it. I mean, he even made a hexadecimal joke. Now, come on, now hexadecimal base 16. I laughed my head off. I thought it was hilarious, but like I want to remember that. Well, I'll tell you, and I'll mention this again whenever I get to class. In Thursday's class, today we're going to go over this week's lesson. But in Thursday, when we have class on Thursday, I'm going to go over that whole program Thursday. So anyone who's struggling with that, hadn't got it turned in yet, I'm going to dedicate that class to going through it. I know part of it's confusing, especially because it went back to Turtle Graphics, and we really haven't done much with Turtle Graphics. We haven't done anything this semester with Turtle Graphics. And I have that 10-minute Turtle Graphics video I had at the top of the template that you click on and watch. But we're combining that with if statements, if then else statements, if else, and all that kind of stuff. We do not have a mandatory class on Thursday. That is optional for anyone who wants to come get help with that. So you don't have to. If you got the program done and you don't have no problem with it, you don't have to come Thursday. I'm just holding class Thursday for those who need help. There's probably a few people that's in RTI whose grade requires them to be here Thursday, but no, it isn't. Thursday is not a required class. I'll emphasize that too. I'll mention it again as everyone gets in here. But there were a lot of people that struggle with that. I had some people come to class last week saying, "Hey, I'm trying to get this done and I'm confused," and I'm like, "Let's take a look at it." So yeah, there's a few people whose grade is down far enough they have to be here Thursday. But Thursday we're gonna look at that for anybody who wants to come. So it is certainly optional. Now today is of course our mandatory class day. Tomorrow is a mandatory class day since yesterday was our supersized weekend. We didn't have any Monday classes, so we're having Wednesday classes for your Monday classes this week. So I'll get caught up on the A days this week. And then we have parent teacher conferences Thursday night, 4 to 8. So after school on Thursday, if your parents want to come up and visit, if you want to hop in the car with them, come along, come on with them. But we will be here. The teachers will be here at the virtual classrooms until late, late, late. So that's always a fun day. I got yesterday off, but I'm working 2 days on Thursday because I get here at 7 in the morning. So I'll be here at 7 o'clock in the morning until 8 o'clock at night. I'm gonna spend like my whole day, like a couple of days, basically. It's been 13 hours here on the campus. So I will just go home and collapse in a pile, I guess, at the end of that. But, all right, is this all we're getting? It's 12:51. We're going to get moving with our lesson, so people are getting late. But again, I'll remind you. I mentioned this just a few minutes ago. Thursday, if you are still struggling with last week's program, and I know there's a few that are. There's a few. I've had people tell me that. So Thursday, I'm going to go over the program from last week, top to bottom. Help anyone who hadn't got that done. We will do it together in class, step through all of it, and make it as simple as we can on Thursday. You do not have to come Thursday. Yes, it's this Thursday is parent teacher conference. So Thursday is this week. So 2 days from now is parent teacher conference. So good clarification. So this Thursday during class, this time on Thursday, I will go through that. So if you have not got last week's program done and still working on that, come to class Thursday. It's optional class, except for if you're an RTI because your grade's been low for a couple of weeks. then you'll need to be here Thursday. But if you're on the RTI list, you probably haven't got last week's program turned in anyway. And if you got it turned in last week, it's probably not graded. I've got like 130 things to grade because all of my algebra classes had tests last week too. So I've got a whole bunch of tests to grade in algebra. I've got a lot of programs to grade in my 3 programming classes. And I also had in my programming 2 software development classes, they had programs last week. So I've got like stuff I have to grade on every single class last week, and they're piled up huge. So that's what I'll be doing at parent teacher conferences when no parents are here. In between parents, I'll be grading, and as well as tomorrow during the day when I don't have classes. But it'll be a busy week of grading for Mr. Brock. So, but that's it. Thursday, if you need help with last week's program, come to class. We'll do it together. We'll get it done, get it turned in, and then you'll be in good shape. So that will be a good thing. So let's get into this week so we can look at this week. We do not have a program. It's not a program this week. It's just the 5-question quiz after our lesson. So let's get through our lesson so we can move on. All right. Intro to computer science. Look at our grade screen. Let's see. The 4.02 decisions program was last week. So you may, if you get that submitted, it probably does not have a grade. It just shows that you turned it in. So as long as you got it turned in, you're good to go on that. This week, the logic of and, or, and not. The logic of and, or, and not. So that is what's due this week. Next week is a program again. So we need to get last week's program behind us so we can get into this. And this will not use Turtle Graphics next week. So 4.03, let's go take a look. The logic of and, or, and not. The logic of many options. Rock, paper, or scissors. If you choose rock, you beat the scissors, but you lose to the paper. You also tie with rock. So this all depends on what set of rules you're following, right? Because maybe some people will change the rules a little bit on that, saying, hey, my rock's going to crush your scissors. But, that's life. Or well, that's decision making. So winning rock, paper, scissors depends on a few things. What you play, am I going to play scissors or paper? What your opponent plays, and what value you put on those elements. Some could argue that rocks could shred a piece of paper right there, therefore beating everyone. It's going to crush the scissors. It's going to tear right through that paper. But what if you introduce lava? Say, now I'm going to melt your rock. So when writing a program, you can decide what logic you want to follow. I mean, trust us, you'll lava it. Okay. After completing this lesson, you'll be able to identify and use compound logic, which is Boolean expressions, and create and evaluate Boolean expressions for making multiple decisions. Because our if statements before were just if this is true or not. That's all we looked at. This week, we're looking at and, or, not. Let's take a closer look at Boolean logic. There are 3 logical operators that can be used to write compound conditions. This means compares 2 or more conditions. And, or, and not. Search engines respond to Boolean logic. I don't know if you've ever done that in a Google search. It makes it easy to tell Google or YouTube that you want to watch videos that contain cats and sloths, but not goats. Or perhaps you want evidence of Sasquatch or Bigfoot, but not Yeti. I don't want to know nothing about a Yeti. Just tell me about a Sasquatch or Bigfoot. And so you can Google that. And that's at 131,000 results. I bet that's an old search. I bet there's a lot more these days. So there you go. In Boolean logic, the keywords and, or, and not make a major difference in whether a statement's true or false. So let's look at some examples using pizza. So if we have the Boolean condition and, okay, that means both conditions on either side of the word and have to be true for the entire statement to be true. Like if you want a pizza with pepperoni and black olives, then this would be the pizza that would make the choice for you, right? That's what someone would bring you. It has pepperoni and black olives. And you'd say, great, thanks. I'm going to eat this pizza. If we used or, one condition on either side must be true. If you said, I want pizza with pepperoni or black olives, well, there's 3 different pizzas that could show up at your table. Maybe this one that has just black olives, this one on the right that has just pepperoni, or you could get the one in the middle that has black olives and pepperoni, because that meets the or. If it has either one, or, well, this one's got both, so that meets the requirement. But you don't have to have both of them if you use an or. How about not? The condition appearing after the word not must be false. So if you said you would have pizza with pepperoni but not black olives, well, 2 of these choices are now gone. You would only take the pizza that has pepperoni. If it has olives, it did not meet the requirements because you said pepperoni but not black olives. So we could use all this in programming and to check more than one thing. Or not. When you combine 2 Boolean conditions into a compound condition, compound meaning there's more than one, each individual condition is evaluated to either be true or false. So this will come in handy when you write code that includes multiple decisions, so your program knows when to execute certain blocks of code. So you think you got a handle on Boolean conditions? Let's see. Let's take this little quiz. If we were choosing a number that is both even and greater than 26, but not there's a not greater than 75. Oh, let me see if I can make this a little bigger on our screen. What is the correct? It says there could be more than one. The correct items. A number that is both even and. So here's an and. So it has to be even and greater than 26, but not greater than 75. Select the correct item. So which of these numbers meet this criteria? Got to meet all that criteria, all the this and this, but not this. See any? Man, you thought you were getting out of math class, coming to computer class. But math and computers are so closely related. Both logic-based stuff. All right, put in the chat, folks. What do you think? Which of these meet the requirements? There may be more than one. Let me see. Yes, there's more than one. I believe so. I believe there's more than one. So let's see. There we go. Someone, Noel has said 74. Thanks, Noel. Let's see. That's an even number. It is greater than 26. It is not greater than 75. Okay. Olivia and Kinley weighed in with Rocky. Says, wait a minute, there's another one. 30 is also even and greater than 26, but not greater than 75. Is that it? Just 2? See, 26. 26 is even, but it's not greater than 26. So it failed right here because both of these have to be true. 94 is even and greater than 26, but it failed this. It says not greater than 75. Well, that is greater than 75. 27 is not an even number. 18 is not greater than 26. So that should be it. Very nice. Got another one. Pizza with mushrooms or black olives. So we'll just number these 1, 2, 3, 4, 5. Which of these pizzas would satisfy this condition? 1, 2, 3, 4, 5. There could be more than one pizza that we can deliver if they want mushrooms or black olives. 1, 2, 3, 4, 5. What do you think? Rocky says we could have number 3. It's got mushrooms and black olives. So that certainly meets the requirements of or. Kinley says we could have a lot more pizza than that. We can have this pizza, this pizza, this pizza, and this pizza. Is that true? Do all of those meet the requirements? This says they want pizza with mushrooms, or, which means it doesn't have to have mushrooms, if it has black olives. So if it has mushrooms or black olives. Let's see. This one has black olives. Okay, good. This one has black olives and pepperoni. Well, it meets the black olives requirement. This has both. This has mushrooms. This just has pepperoni. That is not true for this. So that's great job. There are 4 pizzas. 4 pizzas that meet the requirements. All right, what's this one? A word that begins with the letter B or U. Here's our key word. And we got an or and an and ends in ing or ed. So we've got 2 ors and an and. So we can number these 2. 1, 2, 3, 4, 5, 6, 7. Or you can type the words. Which words meet all of the requirements?
So on yours, we're just looking at those 2 things.
Take some thinking. This is where it gets difficult in programming. Thinking through the logic. Okay, so if I'm trying to get this word, what are the requirements? Well, let's look at them one by one. Just surprisingly, does this meet the requirements? Does it begin with the letter B or U? No, it doesn't. So right there, we don't have to check the rest because it's already failed. So that was not it. Demoted. That does not start with the B or U. Unicorn. Does that begin with a B or U? It does begin with a U, but we've also got to be and ends with ing or ed. Does unicorn end with ing or ed? It does not. So that throws that one out. It met half of the requirements, but it did not meet the requirements after the and. Understood. That begins with a U. So let's see that. Does it end in ing or ed? Oh, it does not. It ends in od. How about unlikely? Starts with a U. Does not end with ing or ed. How about bounced? Begins with a B or U. It does. And ends with ing or ed. Oh, it ends in ed. So starts with a B, ends in ed. It meets all the requirements. How about boarding? Begins with a B, ends with ing. Okay, it looks like 2 of them out of the 7 meet all the requirements. All those requirements. Okay, here's the 4th one. Oh, this one's good. A character that is a superhero and part of the Avengers, but is not able to fly. Which of these is a superhero, is part of the Avengers, but cannot fly? Not able to fly. For you Marvel folks, see, Kinley says, well, Black Widow meets those requirements, Captain America meets those requirements, and the Hulk meets those requirements. Rocky, Black Widow, Captain America, Hulk, he agrees. Oh, you had Spider-Man, someone says Spider-Man. Does Spider-Man fly? He really does not fly, does he? He swings and jumps, but technically really doesn't fly. Wonder Woman is also not part of the Avengers. Iron Man is a superhero that is part of the Avengers, but he can fly with his rocket thrusts and stuff. Let's see if we're right. Let's see if we're right. Yes, good job. You got the 4 of the 7. Nailed it. 4 out of 4. Good job. So that kind of gives you a good idea of how and, or, and not work together to help you be able to test different conditions. All right, let's look at page 3. Compound expression. So how would we write this in code? So we've done this. If homework equals done, print, play video games. That's what I've been looking at the last few weeks. If, and we check this, is this true? Whatever's in the parentheses, is that true? Homework equals done. But if we had 2 conditions, maybe what if the homework equals done and we had to have this and chores equal complete. So your homework has to be done and your chores have to be complete. Then print video games. So if one of these is done and not the other one, you would not be able to play video games, right? So that's how the and comes into play. Python would take no action unless both conditions are true. So maybe you can talk mom or dad into this deal. If homework equals done or the chores are complete, then I can play video games. Maybe you got a lot of homework. Oh, it's going to take forever. Well, let me go do my chores. Chores are done. Can I play video games? I can, because it's or. One or the other. I don't have to have both. As long as I've done one, I can play some video games before I have to do the other. So either one is true. How about this? If homework equals done, okay, got all your homework done, and not, and so this has to be true, and this has to be false. Not chores equal complete. So I've got the homework done, but I do not have the chores equal done. So thank you for doing your homework. Please finish your chores. That's what it would print. So if that's both true, it's true that you've done your homework, and it's true that you've not done your chores. No video games just yet. All right, let's look at a program that uses these in the program. Logical operators. Define main. A equals 50. So we're doing another one of these facts about A again. If, okay, here's our if statement. We're testing something. A is greater than 10 and A is less than 75. So both of these have to be true because we put and. Print A is between 10 and 25. That makes sense. If A is less than 10 or A is greater than 75, because there's no way both of those could be true. First off, A could not be less than 10 and greater than 75. That would never be true. But or could be one or the other. Then print is less than 10 and greater than 75. If not, A equals 10. If A is not equal to 10, print A is not equal to 10. And that's the end of the program. Let's run it and see what happens. Facts about A. A is between 10 and 75, and A is not equal to 10. Pardon. So in our program, we had A was 50. So that means it is between 10 and 25, and it's not 10. Let's change it to 10, see what it does. Nothing prints. Nothing, because when we said A equals 10, let's see the 3 things it checks. Is A greater than 10? No, it's not. It's equal to 10. And it doesn't even matter what the and is because it's already failed right here. How about is A less than 10? No, it's not because it's equal to 10. So this one has an or, so we have to check the other condition. A is greater than 75. Is 10 greater than 75? No, 10 is not greater than 75. So it failed because neither one of those were true. So it does not print this. If A is not equal to 10, well, it is equal to 10. So this is not true. It's not 10. It is 10. So that's why nothing printed other than just saying facts about A. Okay, I don't have any facts about A. Let's make A negative 10. I'll put a space over here. Negative 10. Now A is less than 10 or greater than 75, and A is not equal to 10. All right, let's look at some more conditions. Logical operators. Answer equals input. Okay, so this is going to be an input statement. Which frozen treat do you like? Enter A if it's ice cream or B if it's popsicles. So we're asking the user when they run the program to tell us which one you like better. Oh, this is a good use of the OR statement. If answer equals A or answer equals capital A, because maybe even though this has a capital A, maybe they won't type A, they'll just hit the lowercase a. And they really mean the same thing. So if they say A or capital A, either one of them, or either one of them, then we'll print all this stuff. Else if, right, if that's not true, check to see if this is true. Did they say lowercase b or uppercase b? And so print the stuff. And that's the end of the program. So it's either going to print A or B unless they enter something different. Like if we run the program and we say F, nothing happens. Because it checked to see if it's equal to A and it checked to see if it's equal to B. And since it wasn't equal to either one, so all right, let's say A. And I'm just doing lowercase a. Even though it has the capital, sometimes people don't listen. They'll just enter an A. Oh, it printed a little graphic of an ice cream cone. Nice. But if I had a capital A, same thing. Let's hit a capital B. Oh, look, it made a popsicle. Little popsicle looking shape. Which would also do that. A lowercase a back to the ice cream, lowercase b back to the popsicle. So that's a good use for the or. We could use that for yes. You put capital yes or lowercase yes or something. You know. And you could put more than one or on there too. You could put or again. All right. Logical operators. Define main. Level equals 22. Hidden character equals yes. Message equals nothing. It's an empty message. So here's what it's going to do. It's going to check. If your level is greater than or equal to 25 and your hidden character is yes, then I want the message to be, congratulations, you unlocked the Sherlock achievement. Else, if that's not true, check this. If that is true, it'll print this and then exit down to here. It'll go past all the other ifs. But if this is false, else check to see if this is true. Is the level greater than or equal to 25 and not hidden character equals yes? So it's not equal to yes. Then you missed your chance to earn the Sherlock achievement. But if that's not true, what about if your level's below 25 and the hidden character is yes? You will earn your next achievement when level 25 is completed. And else, which means if this is not true and this is not true and this is not true, then go ahead and do this. Set the message equal to keep looking for the hidden character. And then at the end, after it does one of those things, it'll say your level is, and tell you your level, and then print the message, whatever the message became. So let's run the program. Your level is 22. You will earn your next achievement when level 25 is complete, because our level's 22 and the hidden character equals yes. So let's bump it up. Let's say we've played for a while. Now our character level is 25. So when it runs it, now this is true, and the message becomes congratulations. You unlock the Sherlock achievement because our level is greater than or equal to 25 and hidden characters. Yes. What if this is no? Level 25, you missed your chance to earn the Sherlock achievement because the level was greater than or equal to 25 and not hidden character equals yes. It wasn't equal to yes. So you missed it. So that's how and, or, and not can be used inside of our if statement to be able to check more than one thing, which is really handy sometimes. Really handy. All right, that is the end of the lesson. Let's look at the assignment that goes with it. Hit start. The three logical operators used to write compound sentences are and, or, and not. Is that true or false? Read the following. If x is greater than 5 and x is less than 10, which of these would make that true? Oh, I like that one. In a compound condition, both conditions on either side of the logical operators and must be true for the overall condition to be true. True or false? So we got 3 multiple choice and 2 true or false, it looks like. What happens when a programmer uses not with a Boolean condition? And which of the following statements test if a student has a grade of 70 or above, as well as fewer than 5 absences? Which one of these would test that? There you go. The logic of and, or, and not. And yes, you can use that in Google searches. Give me a picture of a cat and a sloth, or a video of a cat and a sloth, but not a dog. And so, you can do ands and ors in YouTube searches and Google searches and all that kind of stuff. It's part of programming. The computer understands that perfectly. Perfectly. So, all right, guys, you can probably get this done pretty quickly. Just the 5 questions this week. Remember, Thursday, if you had trouble with last week's program and you need help getting that completed because you got lost or just, I don't know what I was doing, come to class Thursday and I'm going to go through the whole thing. I will do that Thursday. So, any other questions? If not, I'll let you get these done and you can go on. I'll get my Programming 2 students in here in a few minutes. All right, guys, have a great week. I'll see you Thursday or not. Thursday's not required. It's optional.